Good morning, boys and girls. We have another lesson today on the moon's effect with Earth and Sun as far as working as a system. Today we're going to be talking about eclipses, both solar eclipses and lunar eclipses. So have any of you seen an eclipse before? There was a solar eclipse a few years ago that I was doing third grade at the time, and with special glasses, we were able to see it. Maybe some of you saw that, even though you would have been quite young at the time. So solar eclipses and lunar eclipses happen because of Earth, Moon, and Sun's relation to one another. So we talked yesterday about the moon's effect on tides on Earth, because the gravitational pull of the moon pulls water towards moon. And so it can be high at times and then low when the moon's gravitational pull is less. We're going to be reading today about eclipses. I've got this page from our Earth, Moon, and Sun system book. And once again, a little bit from the moon book. Now, objects make shadows when they block light from reaching other objects. Sometimes a moon or a planet moves into the shadow of another space object. This is called an eclipse. So an eclipse is in general when things are blocking light so that something is hidden. A lunar eclipse happens when the moon passes through Earth's shadow. Remember that the moon is lighted by the sun. When the moon moves into Earth's shadow, Earth blocks sunlight from reaching the moon. The moon becomes dark for a while. You can watch a lunar eclipse safely without eye protection. So here is a lunar eclipse. And I'll present my screen and show something from online too. So as you can see, the sun's light is hitting Earth and not the moon. The moon is in the shadow. So even if it would be at a normal time that you would see a crescent shape or a gibbous, whatever it might be in its phases, you would not be able to see it because the sunlight is just passing right over the Earth. And remember that the moon doesn't have light of its own. It needs the sun's light to be able to reflect. Now, what ends up happening is that there's kind of this red halo of light from the sun. So I'm going to show you what that looks like. Oops. Okay. So as you can see, it ends up being kind of red or hidden like this. So it's different than a new moon when you can't see any light at all. Instead, it becomes kind of red. Okay. And here is, and that is one type of lunar eclipse when it's called a blood moon. So the sun's rays would be hitting Earth, and moon falls in Earth's shadow for this lunar eclipse. And it says red light passes through and falls onto the moon. So that is a lunar eclipse. Here's another good explanation of it. We'll get to solar eclipse when the moon is between Earth and sun. But for the lunar eclipse, the sun and Earth block the moon's light, as you can see here. So it'd be red on this side rather than it being any other color. So that is a lunar eclipse. Okay, and going to the moon book, it says, when the sun, Earth, and moon are exactly lined up, a lunar eclipse happens. Like with a solar eclipse, which we'll get to soon, the moon's orbit is not tilted. The Earth blocks off the sunlight that usually lights up the moon. The moon has a reddish glow. Lunar comes from luna, the Latin word for moon. A lunar eclipse can last up to 3.5 hours. So it glows red like this. All right, so that is the lunar eclipse. I was thinking that it wasn't red always, but I think it is. It just can look a little bit different each time. And some of that depends on where you are on Earth as you're looking at the moon. Okay, now for solar eclipse. A solar eclipse happens when Earth passes through the moon's shadow. In some places on Earth, the view of the sun is blocked by the moon. Never watch a solar eclipse by looking right at the sun. This could seriously hurt your eyes. So that's why you have to have special glasses to be able to look at it. So because you are looking at sunlight, even if it doesn't seem like that. So here is the solar eclipse. Okay, so the sun's light is partially blocked. As you can see, this little tiny triangle shows one spot on Earth, a small place where you would not be able to see the sunlight, or you would only see an outline of light. So it is not the whole Earth that can ever experience a solar eclipse at a time, because the moon is small enough that it's not going to block the light from all of Earth. It's smaller than Earth. So like this, these other parts of Earth would not have that solar eclipse. And then if you are not in one of those specific spots, it can be just a little bit partially blocked, the light, but not that perfect black circle with the light around the outside of it, like this. So there's only some places at a time that can ever see that, and solar eclipses do not happen as often. So let's see what it says about solar eclipse from this book. The moon's orbit around Earth is usually tilted slightly compared to Earth's orbit around the sun. Because of this, the moon cannot exactly line up between the sun and Earth. But when the moon's orbit is not tilted, and the moon does line up exactly between the sun and Earth, so that does not happen very often, but when it does, a solar eclipse happens. The moon's shadow falls on Earth. A solar eclipse can last up to 7.5 minutes, so much shorter than the lunar eclipse. And it's when that moon's tilt actually allows it to be straight in line between the sun and the Earth. So here is a little project that it talks about when, okay, it says, this is just an interesting little project. Here's how to make a sun projector to see a picture of a solar eclipse. You can poke a pin through the center of a piece of heavy paper that's a little bigger than like the size of this book. Stand with your back to the sun and hold the projector at your shoulder so sunlight shines through the hole. So allowing some sun to come through to the another piece of paper with your hand, and that would be the screen. She's got a piece of paper with the hole, and then the sun comes through to that paper. And move both papers until an image of an eclipse appears on this paper here. That would kind of give you an idea of what a solar eclipse would be like. Once again, very dangerous to actually look at it because we don't look directly at the sun with our eyes. That would damage our eyes. And when you have a solar eclipse, it can be tricky because it makes you think, oh, it's not going to hurt my eyes. It's not enough sunlight, but it would. So that is lunar and solar eclipses. Let me get some pictures of a solar eclipse from online as well. Or actually, I'll do solar eclipse versus lunar eclipse to see the comparison. Okay, so this is what a solar eclipse would look like versus this is a lunar eclipse. And once again, with the lunar eclipse, it's in the shadow and you can see just a little bit of sunlight coming around, so that's why it turns red. And the solar eclipse makes the sun black out, and so that's because moon is between us and the sun. And there you have it. Just like with your assignment yesterday, you'll have a short video to watch explaining the eclipses more and some notes to take as well. So that's all I have for this video. Have a wonderful afternoon. I'll see you soon. Bye.